This is the video for section 1.4, the derivative function. So as you will recall, the derivative at a point, f prime of a, is what to f of x at a? So take a minute to remember that. It is the slope of the tangent line to f of x at a. So the derivative at a point, that's how we defined it. We defined it to be the slope of the tangent line to the graph of f of x at that point. And what we're interested in now is something slightly more general. So instead of just calculating the derivative at a certain point, we can think of the derivative as a function in its own right. And so the derivative as a function, f prime of x, will tell us the slope of the tangent line to f of x at any x. So it becomes a function that when you input an x value, it outputs not the function value, but rather the slope of the tangent line to the function at that point. And this turns out to be a very useful function. So let's take as an example f of x equals x squared minus 2. This is a parabola facing up and vertically shifted down 2 units. So using what we know about the derivative as slope of tangent line, let's see approximately what the slope of the tangent line is at when x equals 1. Maybe it looks like the slope is around 2. And if I look at negative 1 and draw the tangent line, it looks like that slope is around negative 2. So these 2 points give me, these 2 values give me points on the graph of the derivative function. So at the x value 1, my y value is 2, the slope of the tangent line to f of x at 1. And at negative 1, my point on my derivative is negative 2. And since I happen to know what the graph of the derivative looks like, I'm just going to draw it here. It happens to be a straight line. But I'll have to convince you of that here in the next computation. So what we've done before is we have calculated the derivative at a point using the limit definition of the derivative. And you could do that. And if you're still struggling with that, I encourage you to do it now. Calculate f prime of 1. Calculate f prime of negative 1. And you'll see that indeed they are 2 and negative 2. But we want sort of a more general formula that allows us to calculate the derivative at any point. And that is going to be this following definition. So let's take a function f, and let's let x be a value in its domain. Then we'll say that the derivative of f with respect to x is given by the formula f prime of x equals the limit as h goes to 0 of f of x plus h minus f of x over h, provided that this limit exists. So this should look very similar to the previous formula that we had for the value of the derivative at a point, except now x can be any value that's in the domain of f. So we can calculate the formula for the derivative directly and then substitute in x values rather than having to use the limit definition for every different x value. So let's see an example of that. So for f of x equals x squared minus 2, then the definition of the derivative function is f prime of x equals the limit as h goes to 0 of f of x plus h minus f of x over h. And that is the limit as h goes to 0 of x plus h quantity squared minus 2 minus the quantity x squared minus 2 all over h. And if I FOIL out that x plus h squared, I get x squared plus 2xh plus h squared minus 2, and then a minus x squared plus 2, because that minus sign distributes through, all over h. And notice I have a x squared and a minus x squared and a negative 2 and a plus 2, so those all go away. And I am left with the limit as h goes to 0 of 2xh plus h squared over h. And I think you know where this is going. I'm going to factor out an h from the top and have the limit as h goes to 0 of h times 2x plus h over h. And of course, I'm going to careful cancel because h is not 0 since I'm taking the limit as h goes to 0. It gets really small but never equal to 0, so my canceling is legal. And I'm left with the limit as h goes to 0 of 2x plus h. Now substitution is fair game, so I plug in 0 for h, and I am left with 2x. So my conclusion is that the derivative function f prime of x is equal to 2x. Now the geometric interpretation of this function, well, think about what it should be. It's saying that at any point x, the slope of the tangent line to the function x squared minus 2 is given by the formula 2 times x. And from before, that agrees with f prime of 1. Well, it should be 2 times 1, which is 2. And f prime of negative 1 should be 2 times negative 1, which is negative 2. And now see how easy it is to find the slope of the tangent line at any point. So for example, f prime of 0 is going to be 2 times 0, which is just 0. So computing the derivative as a function now allows me to have a formula for the slope of the tangent line at any point to the graph.